The magic of flight? Nope. It's science. Ever stared at a massive airplane and wondered how it lifts off? It looks like magic, but it's pure science. At the heart of it all is the airplane engine, the powerhouse that turns a metal tube into a flying machine. The secret isn't wings alone, it's generating enough thrust to push air backward and send the plane forward. Every flight is a triumph of physics, engineering, and human ingenuity. Today we'll peel back the metal, dive into the spinning heart of these machines, and reveal the science that makes flight possible. Buckle up, let's explore the world of airplane engines. Let's rewind to the early 1900s, a time of incredible innovation and boundless dreams. People had dreamed of flight for centuries, imagining soaring through the skies like birds, a concept deeply rooted in mythology and human ambition. But the real challenge wasn't just defying gravity, it was creating sustained forward motion, a controlled and reliable way to propel oneself through the air. It wasn't just about lift, about getting off the ground momentarily. Gliders, for example, could soar briefly, catching the wind and gracefully gliding for short distances. But sustained, controlled flight needed a continuous push, a reliable source of power, an engine that could keep the aircraft moving forward against the forces of drag and gravity. Early engines, however, were far too heavy and cumbersome, rendering them impractical for flight. They lacked the necessary power-to-weight ratio, that is, until the Wright brothers came along. And their skilled mechanic, Charlie Taylor, played a crucial role in their success. Together, they built a lightweight, 12-horsepower engine from scratch, a remarkable feat of engineering ingenuity. This custom engine used controlled gasoline explosions within its cylinders. These explosions generated the power needed to spin propellers. The spinning propellers pushed air backward, creating thrust and propelling the plane forward, a direct application of Newton's third law of motion. On December 17, 1903, at Kitty Hawk, North Carolina, a location chosen for its consistent winds, their flyer, after numerous attempts, finally took off for a brief but momentous 12 seconds. This short flight was a monumental achievement, proving that sustained, powered flight was indeed possible. That tiny 12-horsepower engine was the ancestor of every airplane engine that has flown since, from piston engines to powerful jet turbines. The real breakthrough? Solving the critical power-to-weight problem, creating an engine strong enough to lift itself and the aircraft. It sparked the aviation revolution, igniting a period of rapid innovation and development in aircraft technology, ultimately making flight a reality for billions of people around the globe. The Wrights' innovation definitively showed that with the right engine design and the right amount of power, the sky was no longer the limit, but rather a vast and open highway. Every modern flight, every commercial airliner, every private jet, traces its lineage back to that first sputtering motor on the sands of Kitty Hawk. The journey from a humble bicycle shop in Dayton, Ohio to the boundless expanse of the sky irrevocably changed the world. It all started with a simple yet ingenious engine, meticulously crafted and tirelessly tested, and that's how, against all odds, we finally got off the ground and into the age of aviation. The story of flight is a relentless pursuit of innovation, and it all began with a spark of ingenuity. After the Wright brothers, engine tech soared, pushing the boundaries of what was thought possible. Piston engines ruled for decades, becoming the workhorse of the skies. They were the heart of legendary planes like the Spitfire, known for its agility and speed, and the Mustang, a long-range escort fighter that dominated the skies. These engines ignited fuel in a controlled explosion to push pistons, a marvel of mechanical engineering. The linear motion was then converted to rotational force, spinning propellers for thrust. It was a direct mechanical approach, elegant in its simplicity. And this technology is still used in small planes today, showcasing its enduring legacy. But as planes needed to reach for more speed and higher altitudes, a new challenge emerged. Piston engines, with their inherent limitations, began to hit their limits. Enter the turboprop, a hybrid solution that bridged the gap. It's essentially a jet engine that spins a propeller, combining the best of both worlds. This made it perfect for efficient short-haul flights, connecting communities with reliable air travel. Then came the turbojet, a revolutionary leap in aviation technology. This design featured no propeller, marking a significant departure from previous engines. Instead, it relied on just a high-speed blast of hot gas expelled from the rear. This created pure jet thrust, propelling aircraft to unprecedented speeds. Turbojets revolutionized air travel, shrinking the world and connecting continents. They were instrumental in making high, fast flight possible, opening up new horizons for exploration and commerce. Today's commercial king is the turbofan, an evolution of the turbojet. A massive front fan pulls in a huge volume of air, setting it apart from its predecessors. But here's the clever part. Most of that air bypasses the engine core. This design results in efficient, quiet thrust, making air travel more sustainable and comfortable. Only a fraction of the incoming air is actually burned within the engine's core. The rest accelerates out the back, creating a powerful propulsive force. This innovative approach boosts efficiency and significantly reduces noise pollution. Turbofans power everything in the modern aviation landscape, from jumbo jets carrying hundreds of passengers to modern airliners connecting the globe. Fighter jets, on the other hand, often use turbojets, or low-bypass turbofans, designed for raw speed and unmatched maneuverability. Some even incorporate afterburners for that extra surge of power when needed. Each engine type evolved to meet new challenges and specific demands, whether it's achieving incredible speed, maximizing fuel efficiency, or delivering sheer power. From the early days of pistons to the sophisticated technology of jets, it's all about matching the right engine to the mission at hand, optimizing performance for the task. The evolution continues, driven by the relentless pursuit of improvement. With each new design building upon the lessons learned from the last, pushing the boundaries of what's achievable. Propellers, jets, and fans, each represents a pivotal moment in aviation history. Each changed how we fly, shaping the world we live in today. And the story isn't over yet. The future of flight promises even more exciting innovations. Not all airplane engines are created equal. Their size and type depend on the plane's job. Small planes use compact piston engines about as powerful as a family car, perfect for low-speed, low-altitude flights. Turboprops bridge the gap, powering regional airliners with efficient, reliable engines for short hops. But for long-haul jets, it's all about the giant turbofan. The GE90, for example, is wider than a 737's fuselage and weighs 9 tons. Built for non-stop intercontinental power. Fighter jets need slim, high-performance engines for speed and agility, often with afterburners for bursts of thrust. Every engine is tailored to its mission, small and efficient or massive and powerful. The right engine makes the right flight possible. From weekend flyers to globe-spanning giants, it's all about matching science to purpose. Engine design is a perfect fit for every flight. That's the beauty of aviation engineering. Let's break down the fascinating process of how a jet engine works. We'll explore the core principles that allow these incredible machines to generate thrust and propel aircraft through the sky. To understand it all, remember these 4 key words. They're the foundation of jet propulsion. Suck, squeeze, bang, blow. These 4 actions, happening in rapid succession, are what make flight possible. First, the giant front fan sucks in a massive amount of air. This is the initial stage of the process, drawing in the necessary oxygen for combustion. Interestingly, some of this air bypasses the core of the engine, but a significant portion enters the compressor section, the next critical stage. Inside the compressor, a series of rapidly spinning blades squeeze the air, dramatically increasing its pressure and temperature. Next, this highly compressed air enters the combustion chamber, the heart of the engine. Here, fuel is precisely injected through specialized nozzles and mixes with the compressed air, ready for ignition. And then, bang! The mixture ignites, creating a continuous, incredibly powerful burn. This controlled explosion generates a tremendous amount of energy. The resulting hot, high-pressure gas then rushes through the turbine section, spinning the turbine blades, which are connected to the compressor and fan via a central shaft, keeping the entire cycle going. Finally, the hot gas blasts out the back through the exhaust nozzle, blow, creating the powerful thrust that propels the plane forward at incredible speeds. This entire cycle happens thousands of times per minute, a testament to the engine's incredible efficiency and power. It's a continuous process, efficiently turning fuel into the forward motion that keeps us aloft. And remember, the bypassed air contributes to both increased fuel efficiency and quieter operation. It's truly a marvel of modern engineering, a complex system working in perfect harmony. All of this incredible activity is happening within that seemingly simple spinning engine. Suck, squeeze, bang, blow, simple words to describe an incredible source of power. That's the fundamental secret behind every jet flight you've ever taken. So, next time you find yourself flying, take a moment to appreciate the engineering marvel happening right there under the wing. That's jet engine magic, made real by the power of science and human ingenuity. The story of airplane engines is one of constant evolution. From the Wright's 12-horsepower motor, piston engines grew into supercharged monsters by World War II, pushing planes to their limits. The real leap came with the turbojet. No pistons, just turbines and pure jet thrust. Early jets were fast but inefficient and short-lived, paving the way for better designs. The Cold War drove rapid advances, more compressor stages, tougher alloys, and afterburners for military power. The high-bypass turbofan invented in the 1960s changed commercial aviation, quieter, more efficient, and able to fly farther. Today's engines use carbon fiber fans, computer-shaped parts, and single-crystal turbine blades that withstand extreme heat. Each generation is quieter, stronger, and more reliable. The journey from simple pistons to today's marvels is a testament to relentless innovation, and the evolution isn't slowing down. Modern turbofan engines do more than just push planes forward, they are complex systems. They generate electricity for everything on board: lights, navigation, entertainment, using generators spun by the engine core. The air you breathe at 35,000 feet, it's bled from the engine's compressor, cooled and piped into the cabin. Hydraulic systems that move massive control surfaces are powered by pumps driven by the engines. Engines are built with safety in mind. They contain broken blades, detect fires, and monitor thousands of data points every second. Redundancy and smart design keep flight safe and comfortable for everyone. Today's engines are self-monitoring, power-generating, air-supplying marvels. They're the heart of every modern aircraft. It's a symphony of science, all working together in harmony. Engines do much more than make thrust. They make flight possible. That's true engineering magic. The evolution of airplane engines is just getting started. Engineers are chasing greater efficiency and a smaller environmental footprint. Geared turbofans use gearboxes for quieter, more efficient operation. Open rotor engines, propeller-like but futuristic, promise big fuel savings, though noise and safety are challenges. Electrification is coming, small planes are going fully electric, while hybrids may power larger aircraft soon. Hybrid systems could use turbines as generators for distributed electric fans, revolutionizing design and cutting emissions. Sustainable aviation fuels, made from plants or waste, can power today's jets and slash carbon footprints. The future will blend efficient turbofans, new engine designs, electric systems, and cleaner fuels. Old ideas are being reinvented with new tech. The next leap in flight is already underway. The sky's the limit for innovation. The engines of tomorrow are being built today. From the Wright brothers' humble motor to today's intelligent turbofans, airplane engines are a triumph of science and curiosity. The next time you feel that push at takeoff, you'll know it's suck, squeeze, bang, blow in action. We've explored the history, compared engine types, and peeked into the future of flight. The story of airplane engines is still being written, and you're part of it. What fascinated you most? The Wright's ingenuity, the jet engine's dance, or the promise of electric flight? Let us know in the comments. Science grows with your questions and ideas. If you enjoyed this journey, subscribe and share. Your curiosity fuels our next adventure. Until next time, keep looking up.